Hi guys, welcome to my YouTube channel. It's me Mohammed Moin. In this video tutorial, I will be discussing the in-depth math institution of logistic regression. So first of all, we should know what is basically logistic regression is. Logistic regression is supervised machine learning, is a supervised machine learning algorithm which is used to model the probability of certain class for any event. It is used when our data is linearly separable and our output is in the form of binary. So so in short, logistic regression is used where we want to classify our data. Logistic regression is a method for classifying data in machine learning. Logistic regression is used where we want to classify our data in two or more classes. One is binary and other is multi-class logistic regression. In binary, we have output in the form of true, false, yes, no, or 0 or 1. So for now, we will be discussing binary class. In the next phase of our video, we will be discussing what is basically multi-class logistic regression is. So let us start with, before explaining logistic regression, we should know why we need logistic regression. As I will explain you, logistic regression is used where we want to classify our data points. So can we classify our data points using linear regression? So first of all, the question came in my mind, can we classify our data points using linear regression? So we should find out whether we can classify our data points using linear regression. If yes, then what? If yes, if we can classify our data points using linear regression, then why there is a need of logistic regression? And if we cannot classify our data points using linear regression, then what are the limitations that we cannot classify our data points using linear regression? And how does logistic regression cover those limitations? Let us find out those limitations first. Now suppose I have a data set that is linearly separated and I have output which is discrete, either 0 or 1. I have defined a threshold 0.5. Above, if my predicted value comes, for example, 0.6, it belongs to class 1. And if my predicted value comes 0.2, it belongs to class 0. So here, as you can see here, I have defined a threshold. If the value is greater than or equal to 0.5, it belongs to class 1. Like here I have mentioned. And if the value is less than 0.5, it belongs to class 0. Here I have mentioned. So here I am plotting my best fit line. And best fit line, or you can say that there is my regression line. Regression. Regression line. Now let us undertake 4 cases and see for all those 4 cases, does it linear regression works or not work. So for example, I take a case number 1. For example, my predicted value x1 comes to be 0. It comes to be 0.2, for example. If my predicted value x1, here this is my present predicted value. If my predicted value x1 comes to be 0.2, which class does it? We have defined if my predicted value comes less than 0.5, it belongs to class 0. So it means it belongs to class 0. Now consider another case. For example, my predicted value comes 0.6. Which class does it belongs? I have said that if the predicted value is greater than or equal to 0.5, it belongs to class 1. So here it belongs to class 1. So I hope it's clear. So for these two cases, case 1, case 2, it works very good and fine. So looking at these two cases, it means we can use linear regression for classification, but not. We will see another 2 cases which will change our opinion as well. For example, if my predicted value comes 1.1, if my predicted value exceeds 1, for example, if my predicted value exceeds 1, it comes here, for example, 1.1. Which class does it belongs? I am considering the case if my predicted value comes below 0.5, it belongs to class 0, and if it is greater than 0.5 or equal to 0.5, it belongs to class 1. But here is the case is different. It exceeds class 1, means it exceeds the value 1. It is from 1.1. Which class does it belong? Or if my predicted value comes minus 0.1. So if my predicted value comes minus 0.1, which class does it belong? Again an issue. Either it belongs to class 1, either it belongs to class 0. if my predicted value comes 1.1 or 0.1, minus 0.1, 1.1 or minus 0.1, it belongs to neither of any of the class, neither it belongs to class 0 or neither it belongs to class 1. So here is an issue. So it works for case 1 and 2, where our predicted value is in the range from 0 to 1. But where my predicted value exceeds 1 or it's less than 0, here comes a serious issue. So not seeing this, it means there is an issue, there is a limitation in our linear regression. Now consider another case. If I have a data point, if an outlier appears, like here, for example, I have an outlier over here. Here an outlier appears. My best fit line will change. Now my best fit line, for example, this is my best fit line L1. Now my best fit line will change to change it from now my best fit line is this. So L2. Now my best fit line is L2. So here we see this is our threshold. So now I see here, now I will draw according to here. So the lines, now this is the point. So it means all these points are wrongly classified. So here's an issue. So there are two limitations of linear regression, using linear regression for classification purpose. One limitation, if an outline appears, my best fit line will change. And second, if my value exceeds 1 or it goes below 0, if my predicted value exceeds 1 or it goes below 0, my linear regression cannot handle that value. So these are the two limitations that I cannot use linear regression for classification purpose. We know that there are two limitations why we cannot use linear regression for classification purpose. If the value exceeds 1 or it goes below 0, our linear regression does not work. Or if there is an outlier appears in my data set, my best fit line changes. So my some data points become wrongly classified. So linear regression does not work for classification purpose. However, we can use logistic regression for classification purpose. How does logistic regression works for classification purpose? Now let us see this. How does logistic regression works for classification purpose? And how does it encounters those two limitations where linear regression fails? How does it cover up those limitations? We will see here. So now look at this over here. I have my data points. As you can see here, blue points are my positive points, black points are my negative points. And we have a equation for straight line. This basically, or you can say linear regression is y is equal to mx plus c. So this is basically my c is basically my y-intercept. M is my you can say that slope. Independent variables, x is, and this is basically my dependent variables. So here you can see that my y-intercept is passing from 0 to 0. So my y-intercept value becomes 0. So I have left it y is equal to mx only. We can also write a straight line equation as y is equal to wtx plus b. So as here we have y-intercept is passing through 0. So b is equal to 0. We are only left with y is equal to wt over x. What is wtx? Now let us see this. So if I have, for example, I have a data point over here x and w is my this plane. W is my plane and x is my data point over here. So what is wt of x? Wt of x is the distance between data point and this plane. Only remember this, wtx is the distance between data point and plane. Now let us consider 4 cases which is clear over further things regarding logistic regression. So let us see our case number 1. This is basically my case number 1. For example, above this line wtx is positive, and below this line wtx is negative. Okay. So if I have a positive data point over here, my y1 will be positive, and wtx as the data point is over here above this line, wtx should be greater than 0. So wtx is greater than 0, so y multiplied wtx1 will come greater than 0. If the value is greater than 0, it means our data point is correctly classified. Now next consider another case. I have a data point over here. This is negative. Why? This is negative. And WTX is below this line. This WTX is less than 0. So minus negative value multiply negative value comes 0 or greater than 0. The value will be positive. So y multiply WTX is greater than 0. Now consider another third case. So if I have a negative data point over here, negative. So as y1 is negative, as this data point is above this line, so it means WTX is greater than 0. So negative multiply positive value means y multiply WTX will be less than 0. Less than 0 means it is wrongly classified. So let us consider another case. I have a data point here, over here, for example. So these are basically two values are my positive values. So y is my positive, and this value is below this line, so WTX is less than 0. So WTX is less than the y multiply positive value multiply negative value. What will the answer? It would be less than 0. As the value goes less than 0, it means that our data set is wrongly classified. If the value is greater than 0, it means. Consider an example which will more clear our understanding about logistic regression. For example, for consider case, for example, I have data points. These are my positive data points from this line. These are my positive data points values, and these all are my negative data points values. That means clear. Above this line, all are the positive data points values, and below these blue points are my negative data points values. For example, now I have to do y multiply WTX. For above this data line, WTX would be greater than 0, and below this line, WTX will be less than 0. So these are my y values. So if I don't now do this, so if minus 2 multiply minus 1 comes out to be positive. So all these points 2 plus 2, I have 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And this when this negative value will multiply by minus 1, it turns out to be positive 2. Now do another thing. Plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. So I have added all these values. But one thing, we have an outlier. I have this negative blue value over here in a positive section. What will it do? Minus 500 multiply 1. Because WTX will be greater than 0. We have 1. It turns out to be minus 500. So minus 500. What does it sum out to be? 2, 4, 6, 8, 10, 12, 12 plus 12, 24, 24, 6, 8, 10, 12. 24 minus 500. What does it turn out to be? Minus 476. Due to this outlier, I cannot correctly classify my points. It comes out to be negative. It must be greater than 0. But it turns out to be minus 476. Now what I will do? This is basically my best fit line or regression line. I can change this best fit line so that I need to draw that best fit line which gives me minimum error. So I will change this best fit line and see how does it important this problem. So now I will change. Now to cover up this issue of outlier, what I will do? If I put this equation y multiply WTX convert this represented by variable z. Here I have represented in the form of variable z. So if I write in the form of sigmoid function like this is my sigmoid function. Here z is y multiply WTX. So it will always give me the value in the form of 0 to 1. So, but in the linear regression case, remember what issue I am facing? I am facing the issue of outliers. So there will be now outliers. It will cover up the issue of sigmoid function. Will cover up the issue of outliers. By using sigmoid function, my value will always lie in the range of 0 to 1. 0 to 1. So there is not an issue of linear regression. In linear regression, we have the issue. My value exceeds 1, but it goes below 0. Now this sigmoid function covers up the issue of outliers plus my value which exceeds beyond 1 or goes below 0. This issue covers up here, which if we use sigmoid function, which is y plus 1 plus e minus z. Z is basically y multiplied WTX. So by always you can see check my value answer will always come, predicted value comes in the form of 0 to 1. It can be 0.2, it can be 0.4, it can be 0.6. Now how to plot it? Now let us see. decimal value always lies between 0 to 1. So in logistic regression, I can say that, for example, this is my threshold value. So it will always lie between 1 to 0. So in the case of logistic regression, my value always lies between 1 to 0. So as we are using sigmoid regression over here, so we have the graph like this. In the case. So guys, this is all from the in-depth introduction of logistic regression. I hope you have learned a lot. If you like this video, do give it a thumbs up and share it with your friends. And do subscribe my channel. See you all in the next video tutorial. Goodbye.